My name is Yiying Li. I'm an assistant professor of material science and engineering at the University of Michigan. In my research group, we look at two of the most important technologies out today. One is microelectronics. This is responsible for all the great advances in computing we have made in the last 50 to 70 years. The second technology is the lithium-ion battery. This is essential to our quest for a clean energy future.
So here in Professor Lee's lab, I'm working on using electrochemistry to create devices that can be used to not only do computations as a computer, but also store memory within the same device. So essentially combining the CPU and RAM.
In my research group, we not only look at these two technologies by itself, but we look at how these technologies can inform the other. How can what we know about microelectronics inform our study of batteries? And how can what we know about batteries inform future developments in microelectronics? Core to all of these technologies that we look at are the materials. This is a representative material, and the process we study, is to look at what happens when we take guest atoms in and out of the material. So for example, if we take this atom, we put it in the material, then we take the atom and we take it out of the material. How does this change the properties of this underlying material? And how can we use it to these exciting technologies that are important for our society?
Our group's breakthrough is in conventional method, we cannot measure the single particles property which is used in batteries. However, using this chip, we can cast the particle on this chip and make a contact with the particle, and we can measure a lot of particles at the same time, and now we can measure the capacity of the particle and its resistance and so on. That is our group's breakthrough.
So the way we move ions in and out of this gas structure is using electricity, which henceforth we call the field electrochemistry. So we create a structure like this. This reservoir is made of this structure, as is this host material, all of which we can add or remove these guest ions. When we apply a voltage across here, this guest ion, which is shown here, if we try to apply a voltage across it, we're able to use this electric field to control the movement of this ion, either like this, and if we reverse the voltage, we can get this ion to move in the other direction. This reaction is fundamental to how this device works, how this lithium-ion battery works. And what we're showing is that just as this reaction can be used to store energy, we can also use this to store the information states of these materials.
I think it's fun to work in this group. The work is challenging and it's a lot, but then once you get those moments like we had with our big breakthrough, it's really rewarding just to see like all your hard work actually become something that can be very helpful in the future.
Since our group is established 2 years ago, so there is a lot of novel topic is working on our group. So it is very excited to working on that kind of novel project, like this kind of single particle measurement method. This one is no one other group has conducted. So if you want to work on this kind of novel work, I can recommend joining this group.
So we're always interested in having new students, undergraduates or graduate students join us. Please email me if you're interested and we can set up a conversation. We have a lot of fun in our group. We go out for lunch during the summer. We have a lot of outings and events. And next week, our entire group, both the undergrads and the graduate students and me, we're all going to Boston for a very exciting international conference.